Welcome to Tech with Kaushik. This is part 11 of our complete practice question series for the AZ-104 Microsoft Azure Administrator exam. Test your knowledge with exam-focused questions covering key Azure administration concepts. Choose your answer before the timer ends, then review the correct answer, clear explanation, and practical exam tip. Let us begin part 11. Question number 431. The topic here is Azure DNS. Review the situation. You have two Azure virtual machines deployed in VNet 1, VM1, 10.0.0.4 VM2, 10.0.0.0.5 VNet 1 is linked to an Azure private DNS zone named corp.contoso.com. The zone contains record 1, txt record 2, a record set to 10.0.0.5 record 3, name record set to record 1.corp.contoso.com record 4, a record set to 10.0.0.4. You attempt to ping VM2 from VM1 by using DNS names. Which DNS name can you successfully use to ping VM2? Option A, record2.corp.contoso.com only. Option B, record2.corp.contoso.com and record4.corp.contoso.com only. Option C, record1.corp.contoso.com and record2.corp.contoso.com only. Option D, record1.corp.contoso.com, record2.corp.contoso.com, record3.corp.contoso.com, and record4.corp.contoso.com. The correct answer is option A, record2.corp.contoso.com only. Record2 is the only name that resolves to VM2's IP version 4 address, 10.0.0.5. Ping can therefore use record2 to reach VM2. The incorrect choices fail for the following reasons. B. Record 4 resolves to VM1, not VM2. C. Record 1 is a TXT record and does not resolve to an IP address. D. Record 3 aliases a TXT record name, and record 4 resolves to VM1. Exam tip. A ping target must ultimately resolve through an A or Quad A record to the destination host's address. Review question number 433. Carefully. Consider the following scenario. You have an Azure public load balancer that load balances HTTP, port 80, and HTTPS, port 443, traffic across a backend pool containing 3 virtual machines, VM1, VM2, and VM3. You need to establish Administrative Remote Desktop Protocol, RDP, access that forwards external RDP connections exclusively to VM3. What should you configure on the load balancer? Review each available choice. Choice A, an inbound NAT rule. Choice B, a new front-end IP configuration. Choice C, a load balancing rule. Choice D, a health probe. The appropriate choice is option A. An inbound NAT rule. The requirement is satisfied because inbound NAT rules on an Azure load balancer map a specific port on a front-end IP address to a specific port on a single targeted virtual machine, or NIC, in the backend pool. B. Front-end IP configurations define public IP addresses but do not route traffic to specific virtual machines on their own. C. Load balancing rules distribute traffic across all healthy virtual machines in a backend pool, not a single specific VMD. Health probes determine instance availability for load balancing rules. Remember this distinction for the exam. Use inbound NAT rules for point-to-point management access, like our DPSSH, to specific virtual machines behind a load balancer. Let us examine question number 434. Let us first review the situation. Your organization owns a registered domain name fabricam.com purchased through a third-party domain registrar. You create a public Azure DNS zone named fabricam.com. You need to ensure that DNS records created in the Azure DNS zone can be resolved by clients across the internet. What should you do? Now examine the possible answers. Option A is modify the NS records at the domain registrar to point to the Azure DNS name servers. Option B is create additional NS records inside the Azure DNS zone. Option C is modify the SOA record at the domain registrar. Option D is update the SOA record within the Azure DNS zone. In this case, select Option A, modify the NS records at the domain registrar to point to the Azure DNS name servers. Here is the technical justification. To delegate DNS domain hosting to Azure DNS, you must update the name server, NS, records at your domain registrar with the 4 Azure DNS name servers assigned to the Azure DNS zone. The other choices do not satisfy the requirement because B, creating NS records inside the zone does not delegate authority from the parent registrar. C and D, SOA, start of authority, records are automatically created and managed by Azure DNS and are not modified at the domain registrar for delegation. Keep this examination point in mind. Domain delegation requires updating the parent domain registrar's NS records to point to Azure DNS name servers. Question number 436. Highlights an important distinction. The focus now shifts to monitor alerts. This scenario establishes the key requirement. You have an Azure virtual machine named VM App Server that runs Windows Server. You need to generate an Azure alert whenever more than 2 error-level events are recorded in the system event log on VM App Server within a 1-hour window. Proposed solution: you install the Azure Monitor agent on VM App Server and associate a data collection rule that collects only performance counters. You then create a metric alert on the VM's network in total metric. Does this meet the goal? Focus on the distinction between these options. Option A. Yes. Option B. No. The best answer is option B, no. The reasoning is as follows. The proposed data collection rule does not collect Windows events, and the selected metric does not represent error-level system log records. The requirement needs Windows event collection to log analytics and a log search alert that counts matching records. The remaining options are incorrect because A, a performance counter data collection rule and a network metric alert cannot evaluate Windows system event entries. The key takeaway is use metric alerts for numeric platform or guest metrics. Use log search alerts for conditions based on event log records. We will now analyze question number 438. Review the scenario carefully. You have 3 standalone Azure virtual machines deployed across multiple availability zones in the same virtual network. You need to distribute TCP port 443 traffic across the virtual machines by using a regional layer 4 load balancing service with health probes. Which Azure service should you configure? Choose from the following options. Choice A, Azure Standard Load Balancer. Choice B, Azure Traffic Manager. Choice C, Azure Front Door. Choice D, Azure VPN Gateway. The required response is option A, Azure Standard Load Balancer. This is correct because Azure Standard Load Balancer provides regional layer 4 TCP/UDP load balancing, supports health probes, and can place virtual machines from the same virtual network across availability zones in one backend pool. Now consider why the remaining options are unsuitable. B. Traffic Manager performs DNS-based global traffic distribution. C. Front Door is a global layer 7 HTTP/HTTPS service. D. VPN Gateway provides encrypted network connectivity, not application load balancing. Use Standard Load Balancer for regional layer 4 traffic distribution to Azure Virtual Machine backends. Evaluate question number 440. Against every requirement. We are now working with Azure Load Balancer. Pay close attention to every stated constraint. An Azure subscription contains VM1 and VM2, connected to the same virtual network NSG1, which allows inbound TCP port 443 to both virtual machines LB1, and Azure Standard Public Load Balancer with a front-end IP configuration. You need to configure LB1 to load balance HTTPS traffic to VM1 and VM2. Which 3 actions should you perform in sequence? Move the appropriate actions to the answer area and arrange them in the correct order. The available items are: the first available item is create a health probe and a load balancing rule that uses the backend pool. The second available item is add the NICIP configurations of VM1 and VM2 to the backend pool. The third available item is remove NSG1. The fourth available item is create a backend pool on LB1. The fifth available item is create an availability set. The correct sequence is as follows. The first item is create a backend pool on LB1. The second item is add the NICIP configurations of VM1 and VM2 to the backend pool. The third item is create a health probe and a load balancing rule that uses the backend pool. The key reason is the backend pool must exist before VM NICIP configurations can be added. After the backends are present, create the health probe and the rule that references the frontend, backend pool, and probe. NSG1 already permits HTTPS traffic. A useful examination rule is this. A load balancing rule ties together an existing frontend IP configuration, backend pool, and health probe. The next item is question number 441. Consider this scenario. You manage a virtual network named VNet1 hosting two Windows virtual machines named VM1 and VM2. You need to inspect the detailed network traffic flowing from VM1 to VM2 over a 3-hour period. Proposed solution. From Azure Monitor, you create a metric chart for network in and network out metrics. Does this meet the goal? Available choices. Choice A. Yes. Choice B. No. The correct answer is option B, no. Azure Monitor network in/out metrics provide aggregated data transfer volume, bytes, not detailed packet capture or individual network traffic inspection. Inspecting actual network traffic requires Azure Network Watcher packet capture. The alternatives can be eliminated because A. Aggregated metrics do not capture network packets or facilitate packet inspection. Exam tip. Use Azure Network Watcher packet capture for detailed packet-level network traffic inspection. Proceed to question number 443. Scenario. You have two non-peered virtual networks in Azure, VNet1 hosting virtual machine VM1, VNet3 hosting virtual machine VM4. You need to enable private IP communication between VM1 and VM4. The solution must minimize administrative effort. What should you do? Review the options. Choice A. Establish virtual network peering between VNet1 and VNet3. Choice B. Create a network security group, NSG, and associate it with VM1 and VM4. Choice C. Create a user-defined route from VNet1 to VNet3. Choice D. Change VM4's IP address to match VNet1's subnet range. The best answer is option A. Establish virtual network peering between VNet1 and VNet3. The requirement is satisfied because virtual network peering directly connects two Azure VNets over the Microsoft backbone, providing low-latency private connectivity with minimal administrative effort. The incorrect choices fail for the following reasons. B. NSGs control firewall filtering but do not provide underlying network routing between isolated VNets. C. User-defined routes require a gateway or NBA next hop to route across non-peered VNets. D. Changing IP addresses without changing network infrastructure does not establish connectivity across VNets. Remember this distinction for the exam. VNet peering is the simplest, most performant way to connect two Azure virtual networks. Now consider question number 444. This question moves us into container instances. You need to deploy an Azure Container Instances container group defined in a local YAML file named deployaci.yaml. Proposed solution. From Azure CLI, you run AZ container create and specify deployaci.yaml by using the file parameter. Does this meet the goal? The options are: Option A. Yes. Option B. No. The appropriate choice is option A. Yes. Here is the technical justification. Azure Container Instances supports YAML container group definitions, An AZ container create file deploy ACI.YAML deploys the configuration. B. The proposed Azure CLI command is the supported method for deploying an Azure Container Instance's YAML definition. Keep this examination point in mind. Use AZ container create file for an Azure Container Instance's YAML file. Let us work through question number 445. Begin by examining the scenario. You need to deploy an Azure Container Instance's container group defined in a local YAML file named deployaci.yaml. Proposed solution: from a command prompt, you run kubectl apply f deployaci.yaml. Does this meet the goal? Compare the following options. Option A is yes. Option B is no. In this case, select option B, no. The reasoning is as follows. kubectl applies Kubernetes manifests to a Kubernetes cluster. An Azure Container Instance's YAML definition must be submitted to Azure Resource Manager by using AZ container create file or another supported ACI deployment method. The other choices do not satisfy the requirement because A. Azure Container Instances is not a kubectl managed Kubernetes cluster. The key takeaway is ACI YAML and Kubernetes YAML use different deployment control planes. Use Azure CLI or ARM/bicep for ACI. Question number 446. Scenario. You configure Azure Backup for an Azure virtual machine named VMApp01. During the initial backup process, the backup pre-check status is warning. What can cause this warning status? Available choices. Option A, VMApp01 does not have the latest version of the Azure VM agent installed. Option B, VMApp01 is currently stopped and deallocated. Option C, VMApp01 uses standard HDD managed disks. Option D. The backup policy retains daily recovery points for 30 days. The required response is option A, VMApp01 does not have the latest version of the Azure VM agent installed. This is correct because an outdated Azure VM agent can cause intermittent backup failures, so Azure Backup Pre-Check can report warning and recommend updating the agent. The remaining options are incorrect because B. A deallocated state can prevent a backup operation rather than merely indicate the documented outdated agent warning. C. Standard HDD managed disks are supported for Azure VM Backup. D. A 30-day daily retention setting is a normal policy configuration. A warning pre-check identifies a configuration that might cause backup failure. A critical result identifies an issue expected to cause failure. Question number 447. Requires careful analysis. We are moving to virtual machines. Identify the decisive requirement in this scenario. You have an Azure virtual machine named VMApp1. You receive an Azure maintenance notification indicating that the physical host running VMApp1 requires scheduled maintenance. You need to move VMApp1 to a different physical host immediately to avoid disruption. Proposed solution: from the Azure Portal Overview blade of VMApp1, you move the virtual machine to a different resource group. Does this meet the goal? Eliminate any option that fails a requirement. Consider option A. Yes. Consider option B. No. In this case, select option B, no. The key reason is moving a virtual machine to another resource group is a logical administrative metadata change. It does not redeploy the VM or move its underlying execution instance to a different physical Azure host. To move a VM to a new host immediately, you must select Redeploy on the VM blade. Now consider why the remaining options are unsuitable. A. Moving resource groups does not trigger VM redeployment to a new host. A useful examination rule is this. To move a VM to a different host hardware node immediately during maintenance, use the Redeploy option. Let us examine question number 448. Let us first review the situation. In the Azure portal, you prepare to create a storage account named Block.A01 with the following initial wizard settings: performance, standard replication, zone redundant storage, ZRS, access tier, cool hierarchical namespace, Disabled. You need to change the account kind option to block blob storage. Which setting must you modify first? Choose from the following options. Choice A, Performance. Choice B, Replication. Choice C, Access Tier. Choice D, Hierarchical Namespace. The correct answer is option A, Performance. The block blob storage account kind is specifically a premium performance tier offering optimized for high transaction rates. To select block blob storage, you must first switch performance from standard to premium. The alternatives can be eliminated because B, C, and D, replication, access tier, and hierarchical namespace options depend on the primary account kind selection, which is governed by the performance tier selection. Exam tip. Block blob storage account kind requires selecting the premium performance tier. Apply precise reasoning to question number 449. Analyze the scenario before evaluating the choices. You have an Azure storage account named AZ-104. You plan to use the command line utility AZ-copy to transfer data into AZ-104. To which storage services in AZ-104 can you copy data using AZ-copy? Compare every choice before deciding. Next, option A, blob and file only. Next, option B, blob, file, table, and queue. Next, option C, file and table only. Next, option D, blob, table, and queue only. The best answer is option A, blob and file only. The requirement is satisfied because AZ-copy v10 supports copying and synchronizing data with Azure Blob Storage, blobs/containers, and Azure Files, file shares. It does not support Azure Table Storage or Azure Queue Storage. The incorrect choices fail for the following reasons. B, C, and D, AZ-copy v10 does not support transferring data to table or queue storage services. Remember this distinction for the exam. AZ-copy v10 transfers data to and from Azure Blob Storage and Azure Files only. The next item is question number 450. Consider this scenario. You create an Azure storage account named FileShare01 containing an Azure file share named Documents. Remote users need to map a network drive to the Documents file share directly over the Internet from home Windows 11 computers. Which outbound network port must be allowed on the home computers and network firewalls? Review the options. Choice A, TCP 445. Choice B, TCP 443. Choice C, TCP 80. Choice D, TCP 3389. The appropriate choice is option A, TCP 445. Here is the technical justification. Azure Files SMB drive mapping uses Server Message Block, SMB, protocol, which communicates over outbound TCP port 445. B. TCP 443 is used for HTTPS/REST API/Azure Files over QUIC, but native SMB network drive mapping requires port 445. C. TCP 80 is unencrypted HTTPD. TCP 3389 is used for Remote Desktop Protocol, RDP. Keep this examination point in mind. Mapping drives to Azure Files via native SMB requires outbound TCP port 445 to be open. Let us work through question number 451. Next, we enter the topic of virtual networks. Consider the following scenario. You have configured a point-to-site (P2S) VPN connection on an Azure Virtual Network gateway. The P2S configuration uses self-signed root certificate authentication. You download the VPN client configuration installer package and run it on a new user computer named Client PC2. You need to establish the P2S VPN connection from Client PC2. Proposed solution: on Client PC2, you open services and change the startup type of the IPsec policy agent service to automatic. Does this meet the goal? Now examine the possible answers. Option A is yes. Option B is no. The required response is option B, no. The reasoning is as follows. For certificate-authenticated point-to-site VPNs using self-signed certificates, a client certificate generated from the root certificate must be exported and installed in the current user's certificate store on client PC2. Changing the IPsec policy agent service startup type does not provide the required client certificate. The other choices do not satisfy the requirement because A. The P2S connection fails authentication until a valid client certificate is installed. The key takeaway is self-signed P2S VPN authentication requires installing a client certificate on every connecting client computer. Proceed to question number 452. Review the situation. Resource group RG-AppProd contains a virtual network VNet1 and a virtual machine VM1. An Azure policy named Not Allowed Resource Types is assigned to RG-AppProd with enforcement enabled. The policy parameter blocks creation of the following resource types: Microsoft, network/virtual networks Microsoft, compute/virtual machines. You need to create a new virtual machine named VM2 in RG-AppProd and attach VM2 to the existing VNet1. What should you do first? Choice A. Remove Microsoft, compute/virtual machines from the policy parameter list. Choice B. Remove Microsoft, network/virtual networks from the policy parameter list. Choice C. Add a new subnet to VNet1. Choice D. Deploy VM2 using a bicep file. The appropriate choice is option A. Remove Microsoft, compute/virtual machines from the policy parameter list. This is correct because creating VM2 requires provisioning a resource of type Microsoft, compute/virtual machines, which is blocked by the policy. Connecting VM2 to the existing VNet1 does not create a new virtual network resource, so Microsoft network/virtual networks does not prevent connecting to an existing network. The remaining options are incorrect because B. Removing virtual networks is unnecessary because no new virtual network resource is being created. C. Subnets are sub-resources of the existing VNet and do not address the block on VM creation. D. Deploying via bicep/ARM still fails because Azure policy evaluates resource creation regardless of deployment method. Azure policy blocks creation of new resources matching denied types. Connecting to existing resources does not create new parent resources. Now consider question number 453. Your company plans to implement Azure Blob Storage Object Replication. You must create a standard performance storage account named Storage5 as the source. Hierarchical namespace must remain disabled. An existing general-purpose V2 storage account named Storage2 will receive the replicated block blobs. Select the appropriate options to configure object replication. Choose the correct entry for every drop-down field. Statement 1. Which account kind should you select for Storage5? The blank. Select from Blob Storage, Blob Storage, Storage, General Purpose V1, or Storage V2, General Purpose V2. Statement 2. Which account should you select as the destination storage account? The blank. Select from Storage 1, Storage 2, Storage 3, or Storage 4. The correct value for Statement 1 is Storage V2, General Purpose V2. Standard Performance Object Replication uses a General Purpose V2 account. The correct value for Statement 2 is Storage 2. Storage 2 is the stated target for replicated block blobs. A useful examination rule is this. Object replication requires blob versioning on both accounts, change feed on the source, and a supported GPv2 or premium block blob account kind. Question number 454. The difficulty level here is medium. Scenario. An organization has two on-premises office locations named Branch Site 1 and Branch Site 2. You need to connect Branch Site 1 and Branch Site 2 by using Azure Virtual WAN. Which 4 actions should you perform in sequence? Move the 4 appropriate actions to the answer area and arrange them in the correct order. Build the sequence from the following entries. Item 1. Connect the VPN sites to the hub. Item 2. Create VPN sites. Item 3. Connect virtual networks to the hub. Item 4. Create a virtual WAN resource. Item 5. Create a virtual hub. The completed sequence is: in position 1, create a virtual WAN resource. In position 2, create a virtual hub. In position 3, create VPN sites. In position 4, connect the VPN sites to the hub. The key reason is the virtual WAN is the top-level resource. A virtual hub is deployed within it. VPN site resources represent the branch locations, and VPN site connections attach those sites to the hub for branch connectivity. Exam tip: the normal site-to-site virtual WAN sequence is virtual WAN, virtual hub, VPN sites, and hub connections. Review question number 455. Carefully. Begin by examining the scenario. An Azure subscription named Sub1 contains the following resources: Resource Group RG1 Storage Account Storage 1, located in RG1, Virtual Network VNet 1, located in RG1, an Azure policy with enforcement enabled is assigned with scope, Sub1 exclusions, Sub1/RG1/VNet1 policy effect, append tag environment. Prod to resources tags are explicitly applied to resources as follows: subscription Sub1, cost center, IT resource group RG1, owner, admin 1 storage account storage 1, owner, admin 2 virtual network. VNet 1, no tags assigned. For each statement, select yes if the statement is true. Otherwise, select no. Review statement 1, RG1 has only the cost center, IT tag assigned. Review statement 2, storage 1 has cost center, IT, owner, admin 1, owner, admin 2, and environment, prod tags assigned. Review statement 3, VNet 1 has cost center, IT and owner, admin 2 tags assigned only. The answer to statement 1 is no. RG1 has explicit tag owner, admin 1 and policy tag environment, prod. The answer to statement 2 is no. Storage 1 only has owner, admin 2 and policy tag environment, prod. The answer to statement 3 is no. VNet 1 is excluded from policy and has no tags assigned. Remember this distinction for the exam. Resource tags are not inherited automatically from parent resource groups or subscriptions. Now consider question number 456. The focus now shifts to Network Watcher. Review the situation. You need to grant a user named admin1 the required permissions to enable Network Watcher traffic analytics for an Azure subscription. Proposed solution: you assign the Traffic Manager contributor role at the subscription level to admin1. Does this meet the goal? The options are: Option A, yes. Option B, no. In this case, select option B, no. The Traffic Manager contributor role manages Azure Traffic Manager DNS load balancing profiles. It does not grant permissions to configure Azure Network Watcher flow logs or traffic analytics. Enabling traffic analytics requires network contributor, or owner permissions along with log analytics workspace rights. Now consider why the remaining options are unsuitable. A. Traffic Manager contributor is unrelated to Network Watcher traffic analytics capabilities. Keep this examination point in mind. Traffic Manager contributor manages Traffic Manager DNS profiles, not Network Watcher traffic analytics. Question number 457. Requires careful analysis. Identify the decisive requirement in this scenario. An organization has 3 regional branch offices and a single Microsoft Entra ID tenant. You need to delegate user management permissions to a designated local IT administrator at each regional office so they can manage only the user accounts in their respective office. What should you create and configure in Microsoft Entra ID? Evaluate each option against the stated requirement. Consider option A, administrative units. Consider option B, custom Azure RBAC roles. Consider option C, entitlement management access packages. Consider option D, management groups. The correct answer is option A, administrative units. The requirement is satisfied because Microsoft Entra Administrative Units (AUs) allow subdividing an organization into regional or departmental boundaries and delegating Entra ID administrative roles, such as user administrator, scoped specifically to the members of each administrative unit. The alternatives can be eliminated because B. Azure RBAC roles control access to Azure control plane resources, not Microsoft Entra ID directory objects. C. Entitlement management access packages manage self-service access requests to groups, applications, and SharePoint sites. D. Management groups organize Azure subscriptions, not Entra ID users. The key takeaway is use administrative units in Microsoft Entra ID to delegate user management permissions over regional subsets of users. We will now analyze question number 458. Review the scenario carefully. A Microsoft Entra ID tenant contains a group named Developers. An Azure subscription contains a resource group named RGDev. You need to grant the Developers group the ability to create and manage logic apps in the RGDev resource group. Proposed solution: on RGDev, you assign the logic app contributor role to the Developers group. Does this meet the goal? Review each available choice. Choice A, yes. Choice B, no. The best answer is option A. Yes. Here is the technical justification. The built-in Logic App Contributor role grants full permissions to manage, create, and edit logic apps within the assigned scope, RGDev, satisfying the requirement. The incorrect choices fail for the following reasons. B. The proposed solution meets the goal as Logic App Contributor contains required Logic App Management permissions. Logic App Contributor role grants permission to manage logic apps without granting full resource group administrative control. Proceed to question number 459. We are moving to storage firewalls. Consider this scenario. You have an Azure storage account named STATA01. An on-premises network with public IP range 198.51.100.0/24 must upload blobs to STATA01. An application on VM1 and Subnet 1 of VNet1 must also access the blob service through the storage account public endpoint. The Microsoft Storage Service endpoint is already enabled on Subnet 1. You must deny access from every other public network source. Which three actions should you perform? Each correct answer presents part of the solution. Select exactly 3 answers. Review the options. Choice A. Set public network access on STATA01 to enabled from selected virtual networks and IP addresses. Choice B. Add 198.51.100.0/24 to the storage account IP network rules. Choice C. Disable shared key access on STATA01. Choice D. Add subnet 1 of VNet1 to the storage account virtual network rules. Choice E. Enable allow Azure services on the trusted services list to access STATA01. The choices that satisfy the requirement are option A. Set public network access on STATA01 to enabled from selected virtual networks and IP addresses. Option B. Add 198.51.100.0/24 to the storage account IP network rules, and option D. Add subnet 1 of VNet1 to the storage account virtual network rules. The reasoning is as follows. Selected network mode blocks unlisted public sources. The IP rule permits the on-premises NAT range, and the virtual network rule permits traffic from subnet 1 through its existing Microsoft Storage Service endpoint. C. Shared key access controls an authorization method, not the permitted network origins. E. The trusted services exception does not grant ordinary access to the on-premises clients or VM1. A useful examination rule is this. For storage service endpoint access, enable the endpoint on the subnet and add that subnet as a storage account virtual network rule. Let us work through question number 460. Review the scenario carefully. You have 5 terabytes of data stored on on-premises hard drives that you need to import into an Azure subscription using the Azure Import-Export service. Which target storage service can you specify as the destination for the imported data? Compare the following options. Option A is Azure Files. Option B is Azure SQL Database. Option C is Azure Cosmos DB. Option D is Azure Data Factory. The required response is option A, Azure Files. This is correct because Azure Import-Export Service supports transferring physical hard disk data into Azure Blob Storage or Azure Files, Azure File Storage. The other choices do not satisfy the requirement because B, C, and D, Azure Import-Export Service does not support importing directly into SQL Database, Cosmos DB, or Data Factory. Exam tip. Azure Import-Export Service supports Azure Blob Storage and Azure Files destination targets. We will now analyze question number 461. This question moves us into container scaling. Begin by examining the scenario. You need to run an HTTP-based containerized application in Azure. The service must automatically scale replicas based on concurrent HTTP requests, support scaling to zero when idle, and not require you to manage a Kubernetes cluster or virtual machines. Which Azure service should you use? Now examine the possible answers. Choice A, Azure Container Apps. Choice B, Azure Container Instances. Choice C, Azure Container Registry. Choice D, Azure Virtual Machine Scale Sets. In this case, select option A, Azure Container Apps. The key reason is Azure Container Apps provides managed HTTP ingress and request-based auto-scaling, including scale-to-zero configurations, without requiring cluster or VM management. The remaining options are incorrect because B, Container Instances runs container groups but does not provide the same built-in HTTP replica auto-scaling model. C, Container Registry stores images but does not run them. D, VM scale sets require VM and container host management. Remember this distinction for the exam. Use container apps for managed, event-driven or HTTP-driven container scaling. Use container instances for simpler container group execution. The next item is question number 462. You have two Microsoft ASP.NET applications. App 1 runs an IIS on an on-premises Windows Server 2019 physical server. App 2 runs an IIS on an Azure virtual machine that uses Windows Server Core 2019. You need to enable Application Insights performance and usage monitoring for both applications while minimizing application code changes. Select the appropriate action for each application. Select the value that correctly completes each statement. For the first statement, for App 1, you should the blank. The options for this statement are install the Log Analytics agent, install the Azure Monitor agent, use the Application Insights SDK, or install the Application Insights agent. For the second statement, for App 2, you should the blank. The options for this statement are install the Log Analytics agent, install the Azure Monitor agent, use the Application Insights SDK, or install the Application Insights agent. Statement 1 should be completed with install the Application Insights agent. The agent enables codeless IIS monitoring on the on-premises server. Statement 2 should be completed with install the Application Insights agent. The agent enables codeless IIS monitoring on the Azure VM. Keep this examination point in mind. Azure Monitor agent collects machine logs and metrics. Application Insights agent instruments supported IIS applications. Question number 463. You deploy an Azure Virtual Machine Scale Set with initial instance count, 2 minimum instances, 1 maximum instances, 10 scale-out action, increase by 1 scale-in action, decrease by 1. Select the resulting number of running instances. Complete each statement by selecting the appropriate value. The first statement reads, the first scale-out action completes while 2 instances are running, and no additional scale action occurs. How many instances are running? The blank. The available choices are 2, 3, 4, or 5. The second statement reads, 5 instances are running, and 4 successful scale-in actions occur. How many instances are running? The blank. The available choices are 1, 2, 3, or 4. The answer to the first statement is 3. The action changes the count from 2 to 3. The answer to the second statement is 1. The count changes 5 to 4 to 3 to 2 to 1. The key takeaway is auto-scale actions change the current instance count but cannot move it below the profile minimum or above the maximum. Let us examine question number 464. Let us first review the situation. You have web applications deployed across the West US, Central US, and East US regions. Existing app service plans are configured as follows: ASP1, Windows OS, Standard S1 SKU, located in West US ASP2, Linux OS, Premium V2 SKU, located in Central US ASP3, Linux OS, Premium V2 SKU, located in East US ASP4, Linux OS, Premium V2 SKU, located in East US. You plan to deploy a new app service plan named ASP5 using the Linux operating system. In which of the currently used regions can you deploy ASP5? Choose from the following options. Option A is West US, Central US, or East US. Option B is Central US only. Option C is East US only. Option D is West US only. The appropriate choice is option A, West US, Central US, or East US. Linux app service plans are supported in West US, Central US, and East US regions. Existing resource groups or regions can host Linux app service plans regardless of whether Windows plans already exist in those regions. Now consider why the remaining options are unsuitable. B, C, and D. Restricting Linux app service plan creation to a single region is unnecessary as all listed regions support Linux app service plans. Linux app service plans can be created in any region where App Service Linux is available. Review question number 465. Carefully. Consider the following scenario. You plan to deploy multiple Windows Server virtual machines in a virtual machine scale set by using an Azure Resource Manager template. You need a script to install and configure web server software automatically on every instance after deployment. What should you include in the template? Compare the following options. Option A is a custom script extension resource. Option B is Microsoft Entra Application Proxy. Option C is an Application Insights resource. Option D is the new AZ configuration assignment complete. The required response is option A. A custom script extension resource. The requirement is satisfied because the custom script extension downloads and runs a script on each VM or scale set instance, enabling post-deployment software installation and configuration from the ARM template. The alternatives can be eliminated because B. Application Proxy publishes on-premises web applications. C. Application Insights monitors applications but does not install the web server. D. A PowerShell Complete is not a deployable VM extension resource in the template. A useful examination rule is this. Use VM extensions in ARM or Bicep when guest operating system configuration must run after a VM is provisioned. The next key item is question number 467. Next, we enter the topic of Network Watcher. Focus on the following situation. An Azure subscription contains VNet1 in East US. Network Watcher is enabled in East US, but the Microsoft Insights resource provider is not registered. You need to create a new virtual network flow log for VNet1 and store the raw flow data. Which 3 actions should you perform? Each correct answer presents part of the solution. Select 3 answers that satisfy the requirement. The relevant choices are as follows. Now examine choice A. Register the Microsoft Insights resource provider. Now examine choice B. Create or select an Azure storage account. Now examine choice C. Create a virtual network flow log targeting VNet1. Now examine choice D. Create an Azure Network Watcher connection monitor. Now examine choice E. Register the Microsoft Operational Insights resource provider. Now examine choice F. Create a new network security group flow log. Select option A. Register the Microsoft Insights resource provider. Option B. Create or select an Azure storage account. and option C, create a virtual network flow log targeting VNet 1. Here is the technical justification. Virtual network flow logs require the Microsoft Insights provider and write raw flow records to an Azure storage account. Creating the flow log for VNet 1 enables collection for the target network. The incorrect choices fail for the following reasons. D. Connection monitor tests and monitors connectivity rather than recording all VNet flow records. E. Microsoft Operational Insights is not required for raw flow log storage. F. New NSG flow logs can no longer be created. Virtual network flow logs are the replacement. Exam tip. For new deployments, use virtual network flow logs rather than NSG flow logs. Now consider question number 468. Consider this scenario. You plan to deploy an Azure container instance using the following Azure Resource Manager, ARM, template JSON fragment. Select the statement completion choices based on the ARM template. Review each blank and choose the most appropriate option. Review statement 1, Internet users the blank. Choose between can connect to the container from any device, cannot connect to the container, or can only connect to the container from devices that run Windows. Review statement 2, if the container process exits with a non-zero exit code, the blank. Choose between the container will restart automatically, the container will only restart manually, or the container must be redeployed. For statement 1, select can connect to the container from any device. Exposed via public IP on HTTP port 80 to any web client. For statement 2, select the container will restart automatically. Restart policy on failure restarts the container after a failed process exit. Remember this distinction for the exam. In Azure container instances, restart policy, on failure automatically restarts containers when process execution fails. Evaluate question number 469. Against every requirement. We are moving to Azure policy. Pay close attention to every stated constraint. An Azure subscription named Sub1 contains resource groups RG1 and RG2. You must use least privilege Azure RBAC assignments to meet these requirements. User 1 can create policy initiative definitions in Sub1. User 4 can assign policy initiatives to RG2. Select the appropriate role assignment for each user. Review each blank and choose the most appropriate option. Review statement 1, assign user 1 the role of the blank. Select from contributor for RG1, contributor for Sub1, security admin for RG1, or resource policy contributor for Sub1. Review statement 2, assign user for the role of the blank. Select from contributor for RG2, contributor for Sub1, security admin for Sub1, or resource policy contributor for RG2. Statement 1 should be completed with resource policy contributor for Sub1. This is the least privilege policy role at the definition scope. Statement 2 should be completed with resource policy contributor for RG2. This grants policy assignment management at the required resource group scope. Keep this examination point in mind. Scope a policy management role at the level where the definition or assignment must be created. We will now analyze question number 470. Begin by examining the scenario. An enterprise hosts a stateful web application across 6 Linux virtual machines configured as a backend pool behind an Azure load balancer named LBWeb. You need to ensure that client requests from the same user browser are routed to the same backend virtual machine for the duration of the session. What should you configure? Review each available choice. Choice A, change the load balancer protocol to UDP. Choice B, set session persistence to client IP and protocol. Choice C, enable floating IP, direct server return. Choice D, set session persistence to none. The correct answer is option B, set session persistence to client IP and protocol. The reasoning is as follows. Client IP and protocol uses a 3-tuple hash of source IP, destination IP, and protocol. Successive connections from the same client IP using the same protocol are directed to the same healthy backend instance. A. Changing the transport protocol does not configure affinity. C. Floating IP changes packet addressing behavior for the backend and does not provide session persistence. D. None uses the default 5-tuple distribution and can send new flows from the same client to different backends. The key takeaway is client IP is 2-tuple affinity, client IP and protocol is 3-tuple affinity, none uses the default 5-tuple distribution. Proceed to question number 471. This question moves us into public IP addresses. Scenario. An administrator plans to deploy a public Azure standard load balancer named LBR Corp Prod. The subscription contains 3 public IP addresses, IP Pub 1, IP version 4, standard SKU, static allocation, zone redundant IP Pub 2, IP version 4, legacy basic SKU, static allocation IP Pub 3, IP version 4, legacy basic SKU, dynamic allocation. Which public IP addresses can be assigned to LBR Corp Prod? Available choices. Option A, IP Pub 1 only. Option B, IP Pub 2 only. Option C, IP Pub 1 and IP Pub 2 only. Option D, IP Pub 1, IP Pub 2, and IP Pub 3. The best answer is option A, IP Pub 1 only. This is correct because a standard load balancer frontend requires a standard SKU public IP address. IP Pub 1 is the only listed address with the required SKU. The other choices do not satisfy the requirement because B, IP Pub 2 is a legacy basic SKU public IP and is incompatible with a standard load balancer. C, the set includes incompatible IP Pub 2. D, both IP Pub 2 and IP Pub 3 use the incompatible legacy basic SKU. Match load balancer and public IP SKUs. Standard load balancer frontends use standard SKU public IP addresses. The next item is question number 472. Review the situation. An administrator exports an Azure Resource Manager, ARM, template for a storage account named StorePap01. The template contains the following resource definition properties: type, Microsoft storage/storage accounts kind, storage v2 SKU, standard_LRS access tier, hot supports HTTPS traffic only, true network ACLS, default action, allow, bypass, Azure services, IP rules, virtual network rules. For each statement, select yes if the statement is true. Otherwise, select no. The first statement is, the storage firewall permits an external application server with public IP address 198.51.100.25 to reach StorePap01 over HTTPS, assuming the request has valid authorization. The second statement is, individual block blobs stored in StorePap01 can be transitioned to the archive access tier. The third statement is, members assigned the global administrator role in Microsoft Entra ID can access Azure Files SMB shares in StorePap01 using their Entra ID credentials without further configuration. For the first statement, choose yes. The network default action is allow and HTTPS traffic is permitted. For the second statement, choose yes. Eligible block blobs in a standard storage v2 account can use the archive tier. For the third statement, choose no. SMB identity authentication and appropriate share level/data permissions must be configured separately. A useful examination rule is this: storage network access, data authorization, and Azure Files identity authentication are separate controls. Apply precise reasoning to question number 473. The focus now shifts to backup and restore. Analyze the scenario before evaluating the choices. You have an Azure virtual machine named VM App Server. You perform a backup of VM App Server using Azure Backup, generating a recovery point named Backup01. After Backup01 completes, you make the following administrative updates to VM App Server: change the VM instance size. Attach a new 500 GB managed data disk. An administrator restores VM App Server from Backup01 using the replace existing option. Which post-backup task must you perform again after the restore? Eliminate any option that fails a requirement. Next, option A, attach the 500 GB managed data disk. Next, option B, change the VM instance size. Next, option C, re-enable Azure Backup Protection. Next, option D, recreate the virtual machine network interface. The correct answer is option A, attach the 500 GB managed data disk. The key reason is replaces the VM disks with those represented by the selected recovery point. Because the 500 GB disk was attached after backup 01, it is not part of that recovery point and must be attached again. The remaining options are incorrect because B, replace existing changes the disks, not the existing VM size setting. C, original location disk replacement preserves the protected VM and its backup schedule. D, the existing VM and its network interface remain, the operation replaces disks rather than recreating the NIC. Exam tip. For replace existing, the restored disk configuration reflects the selected recovery point. Post-recovery point disks must be reattached. The next item is question number 474. Consider this scenario. An administrator needs to perform a bulk deletion of obsolete user accounts in the Microsoft Entra Admin Center using a CSV file upload. Which user attribute must be included in the CSV file to identify the target user accounts? Option A. The user principal name of each user only. Option B. The display name of each user only. Option C. The user principal name and usage location of each user. Option D. The display name and user principal name of each user. Option E. The display name and usage location of each user. In this case, select option A. The user principal name of each user only. The CSV template for Microsoft Entra ID bulk user deletion requires only one attribute column to identify user accounts for removal, user principal name, UPN. Now consider why the remaining options are unsuitable. B. Display name is not unique in Entra ID and cannot be used alone for bulk account deletion. C. Usage location is optional and unnecessary for identifying accounts during deletion. D. Display name is not required in bulk deletion CSV templates. E. Display name is not needed, UPN uniquely identifies the accounts to be deleted. Remember this distinction for the exam. Bulk deletion in Microsoft Entra ID requires only the user principal name, UPN, column in the uploaded CSV file. Let us examine question number 476. Next, we enter the topic of Azure Load Balancer. Review the scenario carefully. You deploy an Azure Load Balancer named LB Internal to distribute incoming HTTPS traffic across two virtual machines named VMweb 1 and VMweb 2. You plan to create a load balancing rule. Which two additional load balancer resources must be created before you can configure the load balancing rule? Each correct selection presents part of the solution. Choose every option that satisfies the requirement. Now examine the possible answers. Choice A, an inbound NAT rule. Choice B, a backend pool. Choice C, a health probe. Choice D, a virtual network. Choice E, an application security group. The appropriate choice is option B. A backend pool, C. A health probe. The requirement is satisfied because an Azure Load Balancer rule references three core components: a front-end IP configuration, a back-end pool, containing NICs/virtual machines, and a health probe, to check instance health. Both the back-end pool and health probe must be created before the rule can be configured. The alternatives can be eliminated because A. Inbound NAT rules route external port traffic to specific individual virtual machines and are not prerequisites for creating a general load balancing rule. D. Virtual networks host the target virtual machines, but are not load balancer child resources. E. Application security groups group NICs for network security group rules, not load balancer configurations. Keep this examination point in mind. A load balancing rule requires a front-end IP, a back-end pool, and a health probe. You have completed Part 11 of the AZ-104 Microsoft Azure Administrator Exam Practice Series. Keep building your Azure administration skills by opening the complete playlist and continuing with the remaining parts in sequence. If this session helped your preparation, like the video, subscribe to Tech with Kaushik, and enable notifications for more certification exam practice content. Share your score, doubts, or feedback in the comments. I would be happy to hear how your preparation is going. Thank you for learning with Tech with Kaushik. Keep practicing, and I will see you in the next part.